Okay, so now we're gonna move to next step. Since initial size is gravity column, no, we haven't designed the column yet. Only flow framing is done. We're gonna replicate all the way up to the story floor, all the way up to the 40th floor. So I'm gonna select all this, hit the shift key and then drag. So you select all the stories, and then I'm gonna just copy all the way up. Right? Let's see, everything looks good. So I'm gonna turn off this text section. I'm gonna turn up this section properties. So, okay. But one thing that you should, since I select all and copy, you see that boundary condition was also selected. Somehow I'm gonna select and go to join, restrain, join, restrain, and remove that boundary condition. So let me see. So all the members and copied, right? Basically, but we haven't designed the column and wall yet. So this is, let's say, workshop 2. I'm gonna run this model, entire model, and see. Try to show you the column node takedown. Okay. All right. So you don't have to worry about this deflection diagram. Yeah, this key doesn't work. Okay. All right. So maybe this and moment and release I'm gonna turn up for. All right, since we did include the entire 40, so what you can do is you can just check the any load cases actual force diagram. So you see that this column load takedown, which is a cumulative the actual force based upon gravity area your and the live load, right? So this in red column is the compression forces. So when you can see, obviously you can see maybe the forces is cumulative. So let me just show only bottom floor and the plan view, maybe plan view. Oh, plan view doesn't show it. So you'll see this. Obviously, the corner column has a less gravity area than edge column, but you could take a look at the overall column reactions, right? Actual force diagram. So this is relatively simple. What I can show you, I'm gonna turn on everything. Yeah, this key doesn't work. Oh boy. Right? The column we assign the lateral column, which is the auto selection column. So what we can do the same way. We're gonna set the load combination for steel column design. This is the column 1.4 that 1.2 1.6 live load for steel column design. So I'm gonna select here composite object, select the column, maybe right click. I'm gonna show only just column. Show selected. Right, this is, I think I only showed all the column. Select all this. I'm gonna go design, steel design, and hit the design. So I'm gonna just let ETABS choose the column sizes for based upon the gravity load combinations. All right, so let me just put this one of elevation. So let's see, A. Okay, so I'm gonna zoom in. Okay, so auto selection column section property here. Let me see. Overstress 1.23 because we have only heaviest size is 14 by 500, and also lightest section W10. You know what? Let me just delete, turn off. I'm gonna just adjust my auto lateral column, right? So I'm gonna just hold on. I cannot. I'll convert to the uniform. Wait a minute. I'm gonna remove it. I'm gonna only use W14, right? But I want to include. Do I have a more heavier than no? So I need to bring more heavier sizes. So here, auto selection. No. From the import new properties, AISC 14 table. This is the, I think, the heaviest section. I want to include this. So I import those section. I'm gonna editor column, open, modify, add in this auto selection property. So I add a 550 to 730 more heaviest section. So I'm gonna let the tabs choose because the heavy section I have is W14 by 500, right? Based upon the stress ratio, we need heavier than W14 by 500. So let's see. I'm gonna select again, go to design, column design, steel column design. Okay, go to elevation. So let's see. All right. So still maybe, yeah, we okay, 0.97. Typically I'm shooting for 0.9, 90%. I think this, since we're using the 30 by 45 bay and live load is 100 PSF, we end up with close to the 14 by 730. But at the end, and for the design, the column, we are allowed to do some live load reductions. So basically, maybe we can try the live load reduction. Typically, when you go through this, we are allowed to about 50% live load reduction roughly. So I just changed this. Let me see. Do I have to rerun it or only redesign it? I have to let's see. Probably I don't have to rerun the model. Okay, I don't have to rerun the model. So 50% live reduction is quite significant saving. Yeah, because the code will allow. So here you see that the member size was reduced because I applied the live reduction, right? So here again, steel beam design. I'm gonna go verify all member paths, say okay, and rerun it. So whatever in our original, no, initial auto selection member was replaced by the design section. Okay, I'm gonna check and then check the selection. I'm gonna turn on section name and see member size is updated. Okay, so again, I'm gonna select all the column size that ETABS chose. There are a couple of things that we should aware of it, since we are using shear wall, concrete wall as a backbone, right? This is non-sway frame, so that all the column is basically leaning to this concrete shear wall backbone. so that we are able to assume and use K effective length factor to 1. But if you're using moment frame as part of lateral system, I think that's not the non-sway frame. So you need to really understand philosophy, and because of K effective length factor is very quite sensitive. If you end up with K equal, let's say 1.5, your embrace length slandency effect will be increased substantially. Eventually you end up losing the capacity substantially. So here you could see all the column size. Here you could just turn on your design display design information, which is output P interaction, right? So you could see this maybe the stress ratio, right? 0.9 to 0.9, 0.9, 0.7. Since we chose being a column section of always only just we include W14, maybe some top floor still we have more redundancies, right? So I'm gonna yeah, same thing, gonna turn off. Okay, all right, so this is example of the composite beam design and column design. So I want you to at least finish composite floor framing design on this Thursday. Okay, I'm gonna add one more because maybe because you might be interested in something on a symmetric building layout. So maybe I'm gonna create another video. So if you want to create something more unique geometry, why don't you try? But I think our goal is we need to finish composite floor framing design this Thursday, and yeah, we're gonna have a middle term presentation, likely third weeks or maybe end of October. So we're gonna discuss, but I want you to just spend some time and at least learn this composite floor framing design. All right? Okay.